from Germany on Spunky.
Yeah. Hi, I'm Martin, and since 10 years I'm working at Genode Labs in Dresden, in Germany. So what I was mainly involved there in the Genode framework, I don't know, do anyone know about the Genode framework here? Yeah, someone? Okay. It's like an operating system framework to create operating systems. And yeah, I was involved there in creating the first in-house kernel for Genode, and then in drivers and hardware support, especially for ARM. And after that, I switched a little bit to testing infrastructure and built an automated tester. And then, yeah, I finally ended up with Ada and Spark last year. And to be honest, I'm a total newbie to this. I visited the Ada dev room last year the first time, and yeah, I was very excited about experimenting with it. And then I thought about how can I leverage from this? How can I do some Ada in my own system, in my working system in Genode? And I thought, why not write a kernel for it? Because it's the most fundamental task. I want to trust it the most. And yeah, so first a little bit about Genode in general, because not everyone knows about it. I said that Genode is an operating system framework. It's not actually an operating system. And this framework consists of three parts. First, you see here at the bottom of the picture that Genode runs on several kernels, mostly microkernels. There are a lot of third-party kernels like Nova, SAL4, Fiasco C, or Linux. And there's also this in-house kernel I mentioned that has the beautiful name BaseHW. And on top of that, we have the first component of Genode. It's the core. And what core does, it actually translates from all these different kernel interfaces to the generic Genode API abstraction. So that every component then runs on top of it. Generally is kernel agnostic. You don't have to recompile it normally to use it on a different kernel once you decide to switch. And then on top of it, you have a vast collection of components that you can put together like Lego bricks to create your own individual system. And this individual system can scale from embedded systems up to like desktop systems. We actually, in our office, we use all our own desktop system built on Genode for working. And yeah, you can see there are a lot of drivers for the most common hardware on x86 and on ARM. And then you have these native resource multiplexers like a router for networking, an audio mixer, and so on. Then there are system services like, for instance, the init. This is a very special one because it's used very broadly in Genode because it can dynamically load subsystems. So you can start other applications with it and control them, manage them. And also the services between them and the resources. Then on top of that, you have applications several. These green bricks here are native applications that run natively on Genode. For instance, you have there these depot query and depot deploy. These are tools for the package management which brings Genode. Or for instance, the Scalp manager is like a managing component for our desktop system. Yeah. And then there are a lot of ported programs also because Genode provides also a libc abstraction and POSIX for porting components. And you can see, okay, we have GDB, VirtualBox, GCC, and all the stuff you need normally to work independently. from other systems. So and then a lot of libraries. I have colored them. I have put them with different bricks because yeah, what I wanted to show with these bricks is all the components are very well separated from each other. So what core or what the system does is it applies a very strict organizational structure. So the complexity of the whole system can be managed. So normally all these components don't know from each other. They only see services and they know how to use them, but they don't know from where they come. So normally you have only client-server relations between them and parent-child relations, but the components themselves don't know about from where it comes. And yeah, so I wanted to start here with the base HW kernel because it's an in-house kernel. I know a lot about its internals, and it's very easy to modify. Because the base HW kernel is not really a self-standing kernel. It's a library that is linked against the core of Genode. And it's less than 10,000 lines of code, a lot less if you specialize on one architecture. And these modules that the base HW kernel is made of are also pretty well separated from each other. So you can pick them out and translate them, for instance, or modify them without having to change all the interfaces. Okay, and one special thing about the base HW kernel is, as I said, it's linked against core. So it runs in the same address space, but it's separated from the core functionality through a syscall interface. The syscall interface is very small, because we wanted to keep things very minimalistic in the base HW kernel. It has like 25 public syscalls to user components and 20 private syscalls that can only call core. So they are for internal operation only. Yeah, and yeah, another nice thing about it is it's single-threaded. Our approach was, okay, if we have SMP or something like that, it's enough to have a thread for each CPU, and you simply lock the whole kernel while one CPU is in the kernel, because kernel passes are very, very fast. You get into it and then you get out it and done. You have nothing to block there. You have nothing to. Normally you don't do a lot in there. And so it should be fine with a big kernel lock. Yeah, so this makes this whole kernel only a big state machine that is really good to control, and especially really easy to transfer into other contexts for a newbie like me in Ada and Spark. So I thought it's the perfect goal for me to go for. Yeah. Now I have to get back a little bit. We had an Ada and Spark project last year. That was the main reason why I started to learn this language and to get into it. It's a block encryptor. Unfortunately, a block encryption is a little bit complex, so it's not ready yet. I'd like to show it maybe next year, I don't know. But what we had during the design phase of this block encryptor was in-depth discussion about how to find a good design, how C++ and Ada and Spark can work together. Because the native Genode environment is in C++, and yeah, we don't want to change this in the first step, of course. And so we came up with this design for every Spark package that shall interact with C++, or that shall be called from C++ better. There is a C++ class that has only the public interface declarations, so you can do the public calls on it. And it is bloated to the size of a record in Spark. that this record, this is the object that contains the object layout, so to say. It's like a tag type, if you want so. And yeah, then you can leave all the allocation things out of Spark and Adder. You can allocate your C++ class here and in the C++ world and call your functions. And what they do is they go through some kind of intermediate package that is prefixed with CXX, for instance. And this package does all the conversion between the arguments that are still in C++ without any restrictions. They are all they are all translated to a Spark compliant way to this type to fulfill this type safety. And then the same function is called at the real Spark package. So what this makes is you can have in your C++ world this class that is interchangeable. So you can have in C++ implementation or a Spark implementation. It doesn't matter for the C++ code. It doesn't see this even. And on the other side, it's the same. With the Spark package, I can do all my cool stuff with contracts and stuff without getting annoyed by the fact that it's actually allocated and called by the C++ side. So I wanted to use this approach also for base HW because I wanted to take the base HW design, but I don't want it to re-implement it all in one step because I wouldn't have any intermediate steps where I can test it and see if my approach is really successful. So this let me translate the single modules, pick out single modules of the base HW kernel and replace them with Spark, with Adder implementations. Actually, it's not Spark. I will come to this later. Yeah. So how far did I get? First of all, I had to move all the Adder runtime into the kernel. This was a little bit of work. But fortunately, I had a lot of preparation work done already by the guys from Componalit, by Johannes Kliemann and Alexander Signier. And they helped us a lot with this. They had always an open ear if we had any problems with the Adder runtime on Genode. And there were some quite difficult problems that I couldn't understand with my knowledge. Yeah, once this was done, I started with the data structures on the right side. It's pretty simple. It's only a list, essentially, and a queue, a double linked list and a queue in base HW. But there I had one reason why I wouldn't go for Spark directly. I wanted, but the problem is that base HW is dependent on pointers. And it uses it a lot, and it's a little bit hard to get rid of it in the first step. So I decided to use access types, and unfortunately we don't have borrowing supported yet in the Adder runtime on Genode. So it should be fine still with Adder. Yeah, we can't go to Spark directly. Yeah, then the second step was the signaling in the RPC. And my experience with this was once I had translated the modules and I had managed a huge amount of compiler errors that I had to face. This was really that made me almost crazy, like hours of compiler warnings. But the cool thing about it is once they were implemented, they worked out of the box. And I could not only do some single little tests or something like that, but I could directly put a huge system on it and run it, and it worked. And that's really cool. That's something you're not very accustomed to if you're developing in C or C++, I guess. And the third thing that I started this winter was the scheduler. And this, yeah, it was essentially the same. The scheduler is pretty complex compared to the other modules in the base HW kernel because it is the only kernel that applies the quota-based CPU scheduling system that Genode has. So you can trade CPU time between components. And this makes it a little bit hard. So it's a little bit complex, but anyways, it worked out of the box, and that's really cool. So that's a nice thing. Yeah, and between them, okay, what you might have figured out is all the other modules that are yet not implemented in Ada are, I take them directly from base HW, and they work together with the Ada modules without any modification. Okay, so what are the plans? This year, I'm very definitely want to put all Spunky in Ada. That's the first thing. I want to get rid of the residual base HW code and all the C++ stuff. Then, yeah, we want to publish the block encryptor, and maybe next year I can show it here, hopefully. And until the end of 2020, I want to do a second step. Once I got rid of all the base HW stuff in Spunky, I'm free to redesign it. So essentially, I can try some strategies that I have for getting rid of pointers. That's the main thing, I think, and to convert all Spunky in Spark. And then, of course, I'd really like to prove some basic assumptions about the kernel. Yeah, and in 21, I'm looking for new land. I'm very deliberate about porting the base lib of Genode, so to say, the native Genode environment. So you can have pure Ada components in Genode. And this would also allow me to do another project, namely converting all core, the whole core component of Genode into Ada. And this would be really cool because the core component is like the kernel itself, something that everything on Genode depends on. Yeah, and it would be a nice experiment for me to learn new stuff with Ada and Spark. So yeah, that's it from my side. You can try it out if you want, because actually, yeah, I wanted to show this, I forgot this. If you want not watch system is this, what I'm running on, it's Spunky itself. And you can see here that it's already, yeah, pretty productive, I would say. You can see here, okay, I wanted to start a window manager, for instance, and then I have to grant it the rights to access the services it needs, yeah, because the system doesn't decide this on its own. I will give it a GUI and a pointer shape service, then some clipboard stuff. And I add this component, it starts here. And now that I have a VM, I could blend out the presentation. Now that I have a VM, I could start, for instance, tools, a top view that was programmed by Alexander Böttcher, that is also working in our office. Now I give it the theme VM that I just started and fonts file system. Yeah, I forgot to start the fonts file system. Sorry. Where is the system font configuration? I start this font server, and then now tools top view, so I can try it again. Whoop, and where is it? Here. Okay. So it should start, and we can go out of the control panel and see here something whip. And now we could start this. And Actually, whoop, this is a bit fast. So yeah, you see it's working pretty snappy. And it's already running all the communication part, the RPC and the signaling and the scheduling bit, all in Ada, and that's really cool. I like it. So, thank you for listening, and try out these links. Okay. Any questions?
So you said that you have converted some parts from C++ to Ada, and then you said that you were a little bit happy because it worked out of the box.
Yeah.
In your opinion, experience, what has helped to reach this in the language or tools around the language, or what was the things that have helped
Yeah.
to achieve this?
I think that's only for. Yeah, the question was what has helped that my implementation worked out of the box with Ada and Spark. What do I think helped a lot? And I think, at least in my case, it's that the language disciplined me to find ways to clearly to find a clear solution to the problem. Not to try to find some short breaks if I get into troubles or into problems, but the language doesn't allow for this. It says, no, stop, this is the wrong way, and then I have to turn back and go again and find another design or something like that, and that helps me at least a lot. And the other thing is that I felt that I get a certain, don't know, a certain way of programming while doing this for a long time. I get another kind of thinking about problems, and that's really cool. It encourages you to break things down to simple solutions and not to just use the tooling that is very complex and fancy. And yeah, I think that's it. Yeah.
What was the starting point when you decided to rewrite part of the kernel?
What? Excuse me.
Started you with Ada?
With Ada, at the beginning of last year, I started. Yeah, it's pretty exactly. I started at the beginning of last year. I mean, I had a lot of support. I had some books. I had Johannes Kliemann and Alexander Senier, who already know a lot about Spark and Ada. And you have seen eventually the presentation of Johannes Kliemann. They are not doing the high abstract, say simple stuff, but yeah, and yeah, that's it. Okay. Yeah.
These are actually not my questions. These come from Reddit. So.
Okay.
So
That's
I'm
nice.
just putting them for you, so you know some
Yeah.
of them might have been answered already. So the first question was, if the effort goes well, will we consider having the Spark Ada version replace the original C++ one? And I suppose if not, what would convince them? So you enough to make such a move. So I think you answered.
What was the beginning? Convert what?
If the effort goes well, will we consider having the Spark Ada version replace the original C++ kernel?
Ah, yeah, okay. No, I don't think that this will happen. Because the first thing is we always leveraged from the benefits of having multiple kernels underneath Genode. So what you have normally is that it's very broad testing basis. Yeah, if one kernel behaves one way, the other way, especially the scheduling, for instance, the timing, it's all different. So for us, it had a lot of benefits regarding development and testing. So I don't see the point why to remove the base HW kernel. It's a nice approach and has its benefits. I think especially the other thing is that when I start to redesign the Spunky kernel, it will end up with an approach, I think, that is quite different from the base HW approach. Because all the memory layout has to change. I have to rethink this, and therefore I don't think that this is a replacement for base HW. It's just another way to emerge.
Okay.
Yeah.
Then there was a question, what hardware are you using?
Excuse me?
What hardware are you using?
What hardware are you? Yeah, this is x86 with 64-bit only. I specialized on this platform for the first step, of course, and unfortunately, yeah, I don't have the time to do it all at once. But yeah, I'm planning to go on ARM also, if this is possible. And the base HW kernel already supports several ARM platforms and x86 and RISC-V and stuff. We'll see with time. But for me, the most important thing is x86 because I'm using it on my laptop.
So in your particular case with the Spunky kernel, it would basically be a question of the runtime support from Ada.
What? Sorry. Yeah.
So from your side, from the Spunky kernel, it would
Yeah.
basically be the question of what hardware is supported by the Ada runtime.
Yeah.
Dependent on
Yeah.
anything.
Yeah. The question was from why if I specialize on a certain architecture and if it, from my view, was only a decision because of the support of the ADA runtime. And yeah, I mean, I haven't thought about it a lot. The thing is that this block encryptor project that we had is developed for x86 now. And so it was natural for me to keep this also because it has the most beneficial, the biggest benefit for me. Yeah.
Okay, next question.
Yeah.
Sorry.
Are there any other questions here in the room? Sorry. Yeah. I intermixed them. Yeah. Okay.
You said there is no support for pointer in Spark, but actually there is some support for pointer.
Yeah. Okay. No, sorry. It might be. Maybe you've missed it. I don't know. There is this borrowing support for proving contracts with Spark, but the problem is that this borrowing is not yet supported in the Ada runtime of Genode. So this would be a thing. Yeah, I don't know. It's a little bit more work. This is another thing I want to go into. I missed it in the plans. That I want to broaden the support of the other runtime on Genode because there are several things missing. Yeah. Okay. Yeah.
Okay. So what are some of the significant challenges with converting to Ada?
Okay. The question is, what were the significant challenges when converting to Ada? I must say it wasn't a lot, mostly because I restricted myself a lot in Ada and because I wanted to make it very well fit to Spark later. For instance, I wanted to have pure packages only. I wanted to don't have inheritance yet because I don't know a lot about inheritance now more. But yeah, so I changed a little bit the base HW design, for instance, to not use inheritance that heavily. And these preparation works. Or for instance, I don't wanted procedures with functions with in-out parameters. Yeah, for that I had to change the C++ code a little bit. But I think the main thing were a little detail in the devil. That generics didn't work out of the box because we had no finalization, not generics in general, but generics with how is it called? With incomplete types. If you have an incomplete type and want to put it in a generic, there you need finalization by default, and this isn't supported yet. So Johannes helped me with this a lot again. He knew then after some research that there was a pragma for no finalization. Yeah, thanks. A second, Johannes, you had to.
Just a comment about the pointer support in Spark. The runtime supports the borrowing concept is, as far as I know, purely in Spark, so you don't need any runtime support. But at the point when you started, there was just no borrowing support in Spark.
Yeah.
So you could, in theory, now use pointers, but the support you need is when you are going to prove the code.
Yeah, yeah.
So in theory, it could be valid Spark now.
Okay, yeah. I just blended it out for the first actually, yeah. Okay.
Okay, almost last question, also we're running out
Yeah,
of time.
no problem.
Is the conversion to Ada helping to identify issues that weren't apparent before?
Not real issues, I must admit, because we had already productive systems running on base HW before, and it was tested very well. But what I found definitely were some no, so, I don't know, like gray areas where I was lucky that we didn't have problems with the C++ code before, and because it was programmed a little bit dirty. Yeah, and when I started to fix all the compile errors I had with Ada and Spark, I had to clean up these gray areas, but there were no real issues with the base HW kernel.
Last question, for normal Ada code, but basically from what I understood, the gluing code between C++ and Spark, are you using any static analyzers, and if so, which one?
For the glue code between them, no. I didn't analyze it in general. You mean with a prover or something like that?
Yeah, well, I just, verbatim copy
Yeah.
the question from Reddit.
Yeah, this will be a future task, definitely. I want to get rid of the glue code and the C++ code anyways, so I didn't see a point in analyzing it. Yeah.
So, thanks.
Yeah. Any other questions? No? Okay. Thanks.